Alright, Chapter 8, Balancing Computing Circuits. Measuring means controlling means to find control elements have the common elements for the convert input signal into the output signal, the relation output with the input with the may be proportional inversely with the proportional with the function with the time, etc. And several inputs that are combined. Output may be a sum of the ratio, some of the mathematical relation with the trap of the will to discover the principal example of the proportional elements, applying the expression of the inversely with the proportional elements of the computing elements to the combined with several inputs. Those specific control functions, particularly reset with the rate elements, will be described in Chapter 10 on other classes of the namely of the elements which will produce the output proportional to the square root of the input is discussed as also in Chapter 9. Figure 8.1 shows the block representation proportional element with the block transformer and take the place of the change of the input into an output signal. Show the input going into proportional element and then coming out with the output signal. Some of the kind of balances system produce the transformation balance, specifically form of the feedback arrangements. They have the divide into force balance of the position balance. The force balance operates either direction of the or a null system. Force balance was represented in weighing scale of the beam scale with the indicator with the weight with the deflection with 0 with the null system and then the spring scale. The deflection proportional to the force. This is the deflection. So the deflection system also involves the spring with the quite obviously for the Hooke's law of the force is equal to force times x, which is the force is exerted with the reflector spring equal to the spring rate at a constant times x is the spring deflection. If the w, the weight of the supposed object within the weight, is equal to the force of the exerted of the deflected spring, which is expression of the null system, but also true with the weight of the suspended object equal to the spring rate in constant times x of the spring of the deflection, which is deflection system, where the spring deflection is deflection because the spring deflection is deflection. Since the weight of the equal is, however, the weight is equal to the applied spring rate in constant times the spring deflection. This also means the deflection system predicts the spring because of the fact of the k, which stands for the spring rate, equilibrium, position balance obtained with the displacement, not by forces and forces of balance. Typical example of position balance and flapper nozzle arrangement with a pneumatic controller illustrated in Figure 8.2 with the flapper displays to obtain balance. Alright, shows the supply air with the fixed restriction feedback bellows, the process pressure burden tube, flap rate controller output flapper nozzle system. Position is the response with the two counteracting motions, one from the measuring signal or the other for the output signal with the flapper is now submitted with the train at any moment with the burden tube with the response tube with the chain with the control variable. It rotates the flapper around a pivot A with the which chain with the nozzle back pressure for the chain for the controller output signal the feedback below with the response with the chain with the rotates the flapper with the round pivoted B. In such a direction, the initial clearance between the flapper and nozzle is approach force and balance of the deflection system. Typical example of the force balance deflection system is the galvanometer described with the previous chapter of the torque of the coil is produced with the current flow through it. The motion of the restrained by the hairspring of the coil will rotate with the counter force for the hairspring with the charge of the equilibrium between the two forces obtained. This is the force balance of the deflection system. Is characterized by the fact that the deflection is required to obtain equilibrium. Another application of the deflection system of force balance is found pneumatic system in the pressure duplicator method. The frequency of the converting liquid level into an equivalent air pressure. Figure 8.3 illustrates the principle involved with the top side of the diaphragm. Liquid head in from the atmosphere with the diaphragm nozzle fixed restriction air pressure transmitted air pressure. Exposed to liquid heat. The air pressure emitted with the bottom side of the through the fixed restrict the bottom chamber to communicate directly with the receiver of the nozzle. Open the decree with the diaphragm, move it toward it. Further, open it with the nozzle outlet with more of the air bleeds through the nozzle with the atmosphere lower than is pressure of the chamber to suppose of the liquid level to arrive at the exalting of the additional pressure on the top of the diaphragm and soon with the air supply pressure. Set with the maximum pressure due to the liquid level ahead with the diaphragm and will be determined with the cover of the nozzle with the will make with the pressure of the bottom chamber to arrive until a balance with the reach wherever the force of the top of the bottom of the diaphragm are equal to arrangement is therefore the force of balance of the deflection system is then is that of the new air pressure required with a certain deflection of the diaphragm maintained with the particularly partially with the clove of the nozzle opening. The force balance for the null system, the galvanometer widely with the pyrometer with the millivoltmeter types of some of the potentiometers of the types. When the potentiometer uses the galvanometer with the layer no longer exercise the function of the quantity of the measurement. Figure 8.4 show the typical potentiometer circle with therefore with the two sources, the EMF, the battery, and the thermocouple. They are respectively circled to have the one portion of the slide wire and the common the relative of the action length of the the common portion of the can be either increased or decreased, and show the pentameter electrical force balance with the null system battery and the scale of the slide wire and the galvanometer with the thermocoupling. By means of the slide with the balance condition, the no current flows through the thermocoupling becomes over the bucking after the two EMFs of the common slide wire with a portion of thermocoupled to EMF change of the necessary only to readjust the slide in order to reduce the zero with any of the current flow due with the new condition of the scale can be made with the indicator of the position of the slider can be calibrated in temperature units which is express the reading of the thermocouple over the sole function of the galvanometer to take on balancing the circuit but not magnitude of the change. The balance of the action potentiometer can be compared with the beam of the scale of the mentioned before with one dish of the scale of the carry of the object with the unknown weight with the input with the nose of the wave with the hour added with the opposite with the distance with the deflection of the balance zero with the magnitude with the known with the weights that were added with the curve of the measurement of the output with the input with the potentiometer of the electromagnetic force with the thermocouple to produce with the deflection with the move of the coil over the galvanometer with the cover the obtained with the known of the EMF the loop with the weights which mechanically adjusted until the coil with the deflection zero with the amount of the mechanical adjustment required is read in terms of the variable to measure by the thermocoupler with its force of the balance extreme of the potentiometer represents as much as the millivolt meter of the potentiometer. However, it does not require the deflection of the spring in the order to obtain with the balance condition. It is an outstanding character of the null system compared with the deflection shift of the former required with the outside of the medium and activated by some aid of the power source to make it work, while the later can be self-contained with the response into its own core of the added power of the source may be with the EMF on the battery weights with the air pressure, etc. and the outside medium may either be human operated or some of the automatically operated mechanisms commonly called the feedback. Since the deflection of the system could not be required with additional provision with the peers that have the advantage of the greater simplicity with the null system does have the advantage. However, the beam always return with the same balance condition at the time of the indicator of the measurement of the no mechanical deflection system. In the spring scale, the different for each of the measurement and of the configuration of the mechanical parts. These movements must be free with the history of the non-linearities and in this of the respect with the limitation of the any spring for limitation is influence temperature into the spring members in which may be reduced the inaccuracy with the response of the changing load of the null system have the advantage of the non depending on the deflecting of the spring members also have the greater sensitivity which the millivolt meter and etc. with the volt deflection system of the operator with over the certain range of the 0 to 504 degrees Fahrenheit with the move of the coil will also have the maximum deflection 500 degrees Fahrenheit. Smaller value of the produce corresponding small with the deflection quite visible with the galvanometer potentiometer of the null system that made the same with the fold the deflection at 10 degrees Fahrenheit provided restraint members are allowed with the traffic that have not moved in a sudden change of the beyond with the range of the response of the galvanometer in a potentiometer to give the change that can thus be made much greater than the millivolt meter with a small change with the potentiometer for the can be therefore be sensitive and help with the system at the same time that the dead band of the system is negligible, but the system is unable to respond with the change with the 1 degree Fahrenheit with neither the null system and the deflection system will improve the situation. So for the galvanometer where even the potentiometer is brought with the code of the loop and hence with the function of the unbalanced detector that becomes a relatively little importance whether or not it responds with the linear but the only necessary for the detector for the unbalanced while the determination of the magnitude is obtained with the auxiliary means. The null system and the pneumatic for the character for the protecting with the non-linear is made with the null system, particularly dissolved with the atomic flapper nozzle circle because of the degree of the nozzle opening with the not entirely with the proportion with the transmitted pressure. Pressure duplicator figure 8.3 operates very well as long as the spring constant of the diaphragm is low enough to be ignored if the not indicated the deflection of the diaphragm which if the necessary with the chain with the nozzle opening result of the added force and transmitted air pressure is no longer proportional to the pressure for the liquid head with the metallic diaphragm. An example, the spring constant may be quite high enough for the accuracy of the device would suffer. One of the methods for the producing air would be keep the required motion of the diaphragm in a small spot to approach the null system, which can be done by the making the nozzle diameter relatively large as compared with the motion of the diaphragm on the producing side with the fixed restriction. And one of them may also apply with the principle of the pneumatic of the null balance, which is introduced by the C.B. Moore, which uses ingenious feedback principle, which call for the maintenance of the relatively constant pressure drop across the nozzle, thereby reducing the deflection of the diaphragm considerable. In order to clarify with the involved with converting an arrangement of the figure 8.3 with the null balance equation 6.1 with chapter 6 with the repeat with the here with the equally applies to figure 8.3. 8.1 is the flow restricted over the square root over the which fall over the supply pressure times and minus the transmitted pressure times the transmitted pressure equal to the area and flow area with the restricted over the square root of the pressure transmitted pressure minus the flow area with the supply pressure Area is the flow area restricted resistance is equal to the square root of transmitted pressure minus the reference pressure times the reference pressure and square root of that. In maintaining the diaphragm position, the flow area restricted 1 and 2 to be constant with a maybe d combined with a single constant in K, so that the K is equal to area fixed resistance 2 over the area resistance 1 and the square root times the square root. This can be substituted to equation D1, which makes the K combined single constant pressure supply pressure minus pressure transmitted pressure minus pressure supply minus transmitted pressure times pressure transmitted over pressure transmitted times pressure reference times pressure reference. All right, in this equation, pressure transmitted with the transmitted with the necessary variable in order to make the expression the constant of the whole of the pressure supply and pressure resistance. Pressure reference would have verified direction of pressure transmitted, so that pressure reference is equal to A pressure pressure transmitted, pressure supply is equal to B times pressure transmitted. Where A and B are given the proportional constant, substitute with the equation that is K is equal to BPT times minus PT times PT over PT minus APT minus times APT equal to B minus 1 over A minus 1A. This eliminating all variables obtained within the null system. This is how the changing of the pressure of the supply and the pressure reference, the portion of the pressure transmitted are imperfectly complicated, and nevertheless the ideal null system previously closely approved with the view of the mechanical complexity, however, frequently preferred with the leave of the supply pressure with the constant vary only the reference pressure, even under the condition that possible to reduce the control of the diaphragm deflection curve with the given the figure of the particular cave of the diaphragm deflect with the required with the chain with the transmitted pressure 3 to 18 psi gauge for constant supply reference pressure of the diaphragm motion was 00209 inches be chained with the reference pressure for the proportion of the transmitted pressure of the motion reduced to 00171 inch of the by changing both of the reference supply with the pressure of the portion to the transmitted pressure of the motion was only 0.00011 inches. Principle which with the large variety of the components of the Moore product company with which employ with the variable the reference pressure for the illustrative of the schematic of the figure 8.5 combined with the present duplicating figure 8.3 with the pneumatic relay with the increase of the flow capacity of the transmitted pressure, and show the pilot relay valve with the pilot relay with the variable reference pressure. Air supply going into the air input signal, air atmosphere, and outputs. You have the A, B, C, and D, and E, and F, and G, and H, and I, and J, and L. Alright, the input pressure A with the converter with the into the output pressure, B with the emitting with the air from the supply line, C with the releasing from B, and D with the atmosphere with the input signal, and Q for the diaphragm, E with the move downward for the decrease of the nozzle opening, and therefore Q for the nozzle back pressure, F with the diaphragm assembly, G with the two diaphragm originally connected together, move downward in response to increase nozzle back pressure, the open supply port H emitting air with the increase of the output pressure, the pressure is feedback for the chamber for the I, form of the reference pressure for the nozzle system, balance with the increased signal pressure for the drive of the diaphragm, E with the back nearly to its initial position, increased pressure B with the counteracts pressure F with the restore of the initial position of the diaphragm assembly, compression of the springs L, add to the pressure B, balancing of the diaphragm assembly against the pressure F, therefore necessary for the nozzle for the back pressure for the at all time with the above the output pressure for the fixed amount with the equivalent spring force. This is a constant pressure for the differential cover the nozzle. The method should be the increase of the input signal of results increase of the B and F and I, little display from the original position, thus approach with the null system. The schematic of the figure 8.6 the edge of the mechanism required to also vary the supply pressure for the nozzle system would change the input signal and show the input signal with the output pressure of the air supply. And now we have we have B, E, C, J, and K on the pilot relay valve with the variable supply reference pressure. The air supply was to be designed and passed directly with the fixed restriction of the butt with the flow first with the pressure regulator J with the diaphragm K with the control of the flow pressure, the drop of the crop with the regulated position of the diaphragm, this control of the nozzle back pressure F, this is described above with the nozzle back pressure for the proportion output pressure for the B, with this is the makeup of the pressure supply varying from proportion of the pressure transmitted. In fact, with the diaphragm K, but is not only deflected with the deflection of the E, the diaphragm is minimized, should be not overlooked. The deflection is played at the point which, wherever the effect is negligible, the conclusion which could be the drama they are, the rather for the general validity they have that, or the analysis could be designed greater accuracy within the deflection system. B, with the deflection system is inherently simple arrangement within the null system. C, the advantage of the null system may be improved by reducing deflection foregoing. Also, will imply with a generalized statement that says, since a simpler system is always to be before the deflection system should be chosen unless the greater the accuracy obtainable with the null system is desired. Position balance. The choice between the force of the balance and position balance will be determined by the nature of the input, the output of the both. The force of the balance will be chosen in both over the position of the both balance will be for forward or if the one of the forward of the other position. The decision was generally arbitrary. The primary feedback control variable principally always forward the mechanical electrical. The frequently and signal is used not only for the control but recording the indicating as well with the in-air record. For example, as planning for the displacement indicate the magnitude of the control variable, the output of the mag record of the control of the pressure applied with a certain area and the force. In this case, the electric control is generally with the electromagnetic force control with the moment of the control of the point setting mechanism. Problem arrives at making the choice among the three powerful arrangements. One, you with the force of the primary feedback, with comparing it with the force of the output signal. The output, they're considered by using the positioning mechanism with the pen comparing with the position with the control of the output signal, the converting later with the force of the position. The third arrangement possible, the converting the displacement of the pen mechanism in force with the compare with the force of the controller output signal. With the first possibility, it is rarely, if ever, you with the record control. The main reason is the force of the primary feedback depends on the nature of range of the control variable, but if therefore it does not allow the simple universal balancing mechanism for the force level, the main frequency is extremely low and due to the particular design difficulties mixed with the positioning of the mechanism prefer the inputs over the balancing system. An electric recorder control of the third arrangement converting with the displacement position mechanism of the frequently prefer, for example, the displacement may be linked to a wiper or potentiometer, but therefore regulate with the EMF, which for the control output signal. The pneumatic recorder with control of the most widely used methods of the illustrated figure 8.7 with the control output signal is show the A input signal, output signal, show the input signal, output signal, input signal, output signal, and that show the three typical for the pneumatic panels position balances. The converted into the bell, the displacement with the done with the position input with the signal derived. Measuring means with the simultaneously be the position indicator of the pen. Pneumatic position balance of figure 8.7 illustrate the three typical form of the pneumatic panel position balance with the flapper indicate with A the position of the input signal, linked with the connected with the pen, indicate with the position mechanism by a linkage of the feedback bellows. This is identical with the figure 8.2 with the case B. It is a modification of the case A, which allows for the means of the adjustment of the fulcrum M with the chain with the proportional relation between the input of the output signal. Spring show the illustration has no balancing function, but serves only to hold the flapper against the fulcrum. In this case, see the difference in so forth with the both of the flapper and nozzle position over the chain with the input signal position with the flapper with the feedback signal with the nozzle. The relative position flapper nozzle is the position of the balance to determine the pressure for the output signal. The hydraulic position balance with the output signal in the hydraulic controller. Central flow will be converted into the change of the position of the actuating. Simply hence the position of the balance is generally applied with the figure 8.8 illustrate the hydraulic control of the main components of the which for the four-way valve of the actuating. Similar spool and sleeve of the four-way valve of the both movable, thus the spool may be displaced upward if the sleeve is displaced upward by, and show the four-way valve with the drain supply and the spool with the feedback of the valve with the feedback led by the actuating cylinder with the actuating piston output and input, and show the hydraulic system balancing. The same amount with the relative position as before with the input signal to display with the spool with the above with the chain with the control variable to stretch with the spool with the moves upward of the opening of the port to the top of the actuating piston with connecting the oil supply with the port to the lower port of the actuating cylinder, which also with the connections from the underneath of the piston with the drain with the consequence of the action piston move the downward for the feedback lever hold with the extreme left of the sleeve with the four-way valve against the force of the spring as the actuating piston moves down with the feedback lever with the valve to the motion of the rotating clockwise to move with the feedback sleeve with the upward restore of the initial relative of the position between the spool and sleeve, the end closing ports the actuating cylinder to stop the motion of the actuating piston. Position balance between the spool and the sleeve of the share of the accurate of the position of the actuating piston with the proportional to the input signal of the Wheatstone bridge. Most frequency with the bridge circle with the Wheatstone bridge that's come out of figure 8.9 illustrate with the principle and show the basic weight span with the ACB and E with the pedometer Wheatstone in load of the Wheatstone bridge. The single current with the amp through the resistor E is given them with the amp is equal to the volts times BCA minus AD over AB times C plus D plus AB times AED plus DE plus CE. The equation shows the range of the BC with the AD with the current resistor E with the 0 with the, for example, the resistor A with the resistance temperature with the deflect with the resistance which aim with the temperature with the signal current can be measured with the ammeter with the scale calibrating the degree of the Fahrenheit. With the same, the maximum sensitivity in the bridge of all 5 of the resistors should be approximately the same magnitude of the resistors C, D, and E, or value equal to B. With the equation of the A3 can be written as amp is equal to voltage BA minus B minus A over 5A B plus 3B squared. Nonlinear between chain with the resistant resistor A with the signal and the current flow with the illustrated figure 810 with the nonlinear with the Wheatstone bridge that disappear with the 1 inch with the null balanced single current flows through the resistor E with the distance with the unbalanced with applied with the servo amplifier with the servo meter with the inner shaft with the amplifier position the sliding contact with the slide wire resistance, which is one of the legs of the bridge with the null condition of the BC and AD with the BRIA established with the disturbance of the bridge. Resistor A primary element respond with the chain with the control variable the resistor C with the adjustment and the servo meter with the A chain with the disadvantage with the produce. Described arrangement of the contact the resistance with the sliding contact proceeds with the air and the signal with the method with the prevents illustrating figure 8 11 with the contact control resistance. Show the current in microwave and microamps and 20 degrees to 20 and show the Wheatstone bridge A, B, C, D, and E amperage and E 10 volts. Slide wire A appear with the connection to the turbo amplifier have the known frequency with the no convert with the flow with the unbalanced condition. The illustration show the second and the slide wire with the position shaft with both slide wires A and B are coupled together, controlled by the same servo meter with the range E with the resistance temperature with the detector with the resistor A with the primary element exposed with the control of the temperature with the located with the airborne distance the remaining bridge. Strictly connecting wires are therefore with also with the atmospheric conditions where the resub with the king with the hence for the influence of the wire resistance producing the air and the signal. In this case the 3 wire connection with the wires M, P, and M with the broad with the location of the A resistance change the wire P with again with the no influence with the no balance bridge changing the M and N effect with the 2 different legs within the bridge and compensate with each other since the A change with the temperature of B bus. So applied voltage servo amplifier and self-balancing double slide wire bridge. Okay. To made by the corresponding otherwise compensated but not incomplete with the chain of the B with the obtain with the mains of the slide wire B with the coupling with the A and B provide. So we have a capacitor M, P, and N. A is resistor, G resistor, FD, and A, B, and C, and a supply voltage to a servo amplifier. This changes B with the same with the means of slide wire B with the coupling between A and B provided with for an A position with C plus D equals F plus J, from which the file of the F plus G with the over C plus D equals 1. The null condition of the bridge M and necessary with the A over B equal to F plus G over C plus D. Substitute the equation 8-4 as A over B equals 1 or A is equal to B, which condition for complete compensation strain gauge with the example of the temperature change with the effect with the straight sensitive of the resistor A with the must not be detected in this case with the secondary resistor same material but now exposed to the strength of the mounted colors with the A with the resistor representing the compensation leg within the bridge circuit. Where sliders are projected will be covered with limited life with the expected with the other limits of the elements of the maybe with the Wheatstone bridge with the unlimited resistant chain with the capacity of the inductance with the main replaced with the resistance with the null condition of BC equal to AD with the acceptable adaptability with the null balanced Wheatstone bridge for computing purposes. For example, the let D with the B with the fixed resistor with the D is equal to 1. In this case, the A would equal to BC with the terminal position of the resistor A with the corresponding angular shaft position with the null position always equal to the product of the B and C with the resistance of B and AC. Remember, is represented to control variable to require that the output signal over their product similar B and C, which means with the both of the resistor with the same the magnitude, expose the same control variable with the A is equal to B squared with this with the K with the servo meter with the shaft of the position is proportional to the square of the input. Inversely, B is equal to C with both resistors adjusted with the servo meter with while A is exposed with the control variable to B squared is equal to A and then B is equal to the square root of A. This means with the shaft position proportional to the square root of the input with the for the inside with the resistor with the fixed with the main equal to the unity with the A is equal to C over the D. If the A is position with the servo meter, then its shaft position over the proportion to the ratio of the inputs to C and the D. With the use of bridge circle the computation of the final example over the possibility in here with all the null balance. The Wheatstone bridge is due to the also balance position balance for many purposes. For the computation practical with the prerequisite of the null balance storage bird bridge, the equivalent of the Wheatstone bridge used in the pneumatic and hydraulic circuits. In fact, is the push pull flap flapper nozzle shown in figure 612 is really a Wheatstone bridge. Display with the pneumatic bridge arrangement of Sortberg bridge for the principle that will be illustrated in figure 812 with connection shown with a square root extract from the input signal to apply with the bell of the D and increase the single rotates the lever E with the clockwise about with the roller F and increase the back pressure for the G, nozzle G with the output signal, and this signal is applied with the bells A with the result of the increase over the back pressure for the nozzle A with the back pressure. It is applied with the bell frame over the or equivalent push rod M the downward with the roller K and F with the chain with the fulcrum with the lever E and P with the result of the bolt with the flapper to one move away from the nozzles, counteracting the action with the input signal to 10 with the clove of the nozzle. The null balance is then obtained with the actual active force of the over the D with the pneumatic pressure for the multiplied, and they show the like a diaphragm going into a plunger, some B, A, B, and C shaft, and then some input valves, input and output supply. It's a Sortberg bridge. A bell is aired with the length of the lever for determined by the position of fulcrum, additional force for the producer with a spring with a deflection for the null balance for the negligible spring force for the practical with the constant force balance is established by A is equal to minor A equal to B minus minor B equal to D times minor D equal to C times C. Minor C. A, B, and C with the difference of the lever lengths associated with A, B, and C with the respectively displacement of the roller K and F. Changes simultaneously the lengths of all four levels with all the times B equals C when the A equals D, hence for the A times D times B times C times D times D equals C times D. Dividing the first of the two equations throughout the second yields A over D is equal to B over C, and where A is equal to D times B over C. Furthermore, B is a constant spring force which may be assumed to have unity A and C for the interconnected. They have the same pressure when the A is equal to C. Therefore, A is equal to D over B, D times B over C. That may be written as A is equal to D over 1 times A, or A squared equal to D, or A is equal to the square root of D. The output signal is equal to the A with the input signal equal to D, but hence the output proportional square root of the input is quite opposite for the algebraic relation with the same as the form of the previously described with the Wheatstone bridge. Same variations apply, but therefore, for example, the multiplying signal that requires only the air supply via the restriction shown with the together with the nozzles E with the B cut off with from A and C with the connect with the D with apply on one put in signal to the A and the other C, resulting output signal from the D with equal the product with the input of the signal, same signal applied with the A and C with the output squares the signal with the likewise connection. The dividing of the proportional are possible. The controlling of the differential transformer can be arranged so that the output with equal to the square of the product with the other function input. When they show the power supply amplifier and E and voltage E, voltage 2, 3, and 4, and D 1 and 2. Illustrate with the two differential transformer where voltage E2 with the proportional to E1, the displacement of the core is thus D1. So voltage 2 is equal to K times 1 times voltage 1 times D. The voltage E is applied with the voltage 3, hence voltage 3 is equal to K to the second times K2 times voltage 2. Finally, voltage 4 is equal to K times voltage 3 times distance 4, displacement 4, 2. By substituting voltage 4 with a constant 1, 2, K 1, 2, and 3, times voltage 1 times distance 1 and 2. Combination contains the constant K 1, 2, and 3, and 2 for the single constant K. Voltage 4 is K constant times voltage 1 times diameter distance 1 and 2. Screw for the multiplication input of the distance 1 and distance 2 by making distance 1 equal to distance 2, resulting output square of the input. Chapter 9, Measuring Elements.